Hello everyone. In today's video, we will be solving a problem based on elastic constant. So this is the question, and in this question it says that a cylindrical bar is 25 mm in diameter of 1.2 meter long. It means we have to consider one cylindrical bar. So this is the cylindrical bar which is of 25 mm in diameter, and the diameter of this bar is 25 mm. Of 1.2 meter long, and the length of the cylindrical bar is 1.25 meter. So here, during the tensile test, it is found that the linear strain is 4 times the lateral strain. So when we apply a force in this cylindrical bar, what will happen? This length will get elongated. This length will get increased, whereas this diameter will get reduced due to this applied force. So it says that the linear strain, the elongation is 4 times of the lateral strain. Now, it also says that we have to calculate the Young's modulus, shear modulus, and bulk modulus. So, and it's also given that if the bar is elongated by 0.06 meter, here it's also given that this elongation, when we apply a load, then the elongation of the bar, that is delta L is nothing but the change in length, is equal to 0.06 mm under an axial load of 50 kilonewton, and the applied load here P is equal to 50 kilonewton. So now this is the given data here. D is already given in the question, that is diameter of the bar is 25 mm and the length of the bar is 1.25 meter. And if we convert this meter to mm, then we have to multiply with 1000. So it will come 1250 mm. Now here it says that the linear strain is 4 times the lateral strain. So we can write like this: linear strain is equal to 4 into lateral strain. So here what we know is the Poisson's ratio. The formula of Poisson's ratio is lateral strain upon linear strain. It's written here. So from here what we can do is we can shift this linear strain that side and this for this side. Then the equation will become this one: lateral strain upon linear strain is equal to 1 by 4. And this is the lateral strain upon linear strain is nothing but the Poisson's ratio. Poisson's ratio can be also written as 1 by m. So the value of Poisson's ratio is 1 by 4. So here the bar is elongated by 0.06 mm. So delta L is also given in the question, that is 0.06 mm. So delta L is nothing but the change in length. Here P is also given, which is acting in this cylindrical bar. P is 50 kilonewton. So if we convert this kilonewton in Newton, so we have to multiply by with 1000, that is 10 to the power 3. So it's 50 into 10 to the power 3 Newton. So here the first is we need to find the Young's modulus. So we know the formula for Young's modulus, that is capital E is equal to stress upon E. This sigma, stress is denoted by the term sigma and strain is denoted by this term, that is strain. So here in the question, stress and strain is not known to us. So we know the formula, that is stress is equal to by A. P is the load acting on that bar and A is the cross-sectional area of the bar. So this cross-sectional area and this P is given in the question, that is 50 into 10 to the power 3, and this area, the area of the bar is, we can find by this one, pi by 4 into d square. D is already given in the question. D is nothing but the diameter of the bar. So diameter of the bar is 25. So it will be 25 square. So we'll get this stress value is equal to 101.86 Newton per mm square. Now this strain, we know the formula of strain, that is delta L by L. Delta L is nothing but the change in length and this is the original length. So delta L is already given in the question, that is 0.06 and original length is equal to 1250 and it comes 4.8 into 10 to the power minus 5. So now we can put these values in this main formula so that we can get the value for Young's modulus. So here Young's modulus E is equal to 101.86 upon 4.8 into 10 to the power minus 5. So we get this value. So this value is for the Young's modulus. Now next is to find for the shear modulus, and it is denoted by the term G. So we know the formula for finding the shear modulus, that is nothing but E upon 2 1 plus mu. This mu is nothing but the Poisson's ratio, and this is the Young's modulus. So here this Young's here uh, what happened here? Okay, so here what happened, we know the formula, we know the value for this one. E is equal to 21.22 into 10 to the power minus 5 in upon 2 into 1 plus mu, and we have already known the value of mu, that is 1 by 4. So after equating, we'll get this value. G is equal to 8.48 into 10 to the power 5 Newton per mm square. Lastly, we have to find for the bulk modulus, and bulk modulus is denoted by the term K. So this is the formula for finding the value of K, that is E upon 3 1 minus 2 mu. So we know the value for E as well as for the mu. So we can easily find the value for K here. So just putting all the values here in this equation, we will get this value, that is 14.15 into 10 to the power 5 Newton per mm square, and this value is for the bulk modulus. So this is the next question. So for a given material, Young's modulus is 110 giganewton per meter square and shear modulus is 42 giganewton per meter square. Find the bulk modulus, and the length of the bar is also given, that is 2.4 meter, and when stretched it's 2.5 mm. This is nothing but the delta L, that is change in length. Here this is the given data here. So Young's modulus is already given in the question, that is, and this Young's modulus is denoted by the term capital E is equal to 110 giganewton per meter square. So if we need to convert this giganewton to Newton, then we have to multiply this term with 10 to the power 9, and we have to convert this meter to mm. So we have to multiply, since here meter is square, so we have to uh, multiply with 10 to the power 6. So this is the final value of Young's modulus here, that is 110 into 10 to the power 3 Newton per mm square. Now shear modulus is also given in the question, and this is shear modulus is denoted by the term capital G, that is 42 giganewton per meter square. So same like Young's modulus, here also we have to convert this giganewton to Newton. So 42 into 10 to the power 9 divided by the 10 to the power 6. So this is the final value of shear modulus, that is 42 into 10 to the power 3 Newton per mm square. So now here in the question, the length of the bar is also given, that is 2.4, that is capital L is equal to 2.4 meter. So if we have to convert this meter to mm, then again we have to multiply with 10 to the power 3. So the value becomes 2400 mm, and delta L is also given, see here 2.5 mm. So delta L, that is nothing but the change in length. So here in this question we need to find for the bulk modulus. So bulk modulus is denoted by the term K, and we already know this equation, that is K is equal to capital E upon 3 1 minus 2 mu. This mu is nothing but the Poisson's ratio. So in this equation E is known to us, only the thing is mu is unknown to us. So we have to find the mu value now. So mu can be determined from this equation, that is E is equal to 2g 1 plus 1 by m. So mu can be written as 1 by m. 1 by m also means it's a Poisson's ratio. So we need to find this. So in this equation E is known to us, that is 110 into 10 to the power 3, and G value also known to us, that is 42 into 10 to the power 3. Here only the thing is we need to find this value, so we can get the value for 1, we can get the value 1 by m is equal to this one, and 1 by m is nothing but the mu. Okay, so mu value is 0.309. So we can put all the values in this equation here. So now we know all the values here. So just simply putting all the values here, we can get the value. That value for bulk modulus is equal to 95.98 into 10 to the power 3 Newton per mm square. Thank you.